My name is Erik Hatcher. I'm a committer on the Solar project and the Leucine project. I co-authored a book on Leucine. I don't know if you noticed in your program, but it said the best open source engine plus Ruby, but it's actually a search engine. It's not so general purpose that it's just everything. But so solr. solr is a search server. It came out in open source in January of this year. And it had been brewing at CNET for a while. It was created by CNET, and it's a layer on top of Java Leucine. It's an extremely scalable, fast search server. And what's on top of Leucine is the ability to communicate with it through HTTP, as opposed to writing Java code to communicate with Leucine directly. It also adds caching, replication for load balancing and scalability in that realm. It adds faceting, and a lot of the caching goes along with the faceting. And I'll show you what faceting is in a bit. Highlighting. How many people in here have used Leucine? Wow, handful. So how about solr? Wow, so a great number of hands there for solr. And it also, so Leucine itself includes a lot of these add-ons in terms of highlighting and spell checking. It rolls these things into it and allows it to work automatically through its interface there. It also includes an administrative interface so that you can see the status of the caches and do ad hoc querying and kind of monitor the application itself that way. It's an extremely active community. It's evolving every day. More and more features and scalability and all those types of things are being worked on, as well as Leucine. Leucine has also had an extremely active year and a lot of surge there. So let's see who uses solr. I mentioned CNET. So if you go to shopping.cnet.com or whatever it is, all the faceted browsing and the full text search there is solr powered. The Internet Archive released recently with the solr front end. Netflix, Smithsonian has done something where they've integrated several different back-end integrated library systems into a solr unified front end. Dig also. AOL just recently, this is extremely recent, has done stuff with their sports and music channels in terms of putting solr under the covers of that. I've got a couple of applications that are online as well that are solr powered, and we'll take a look at those as well. Leucine. So Leucine is a Java library, just simply a jar file, that implements an extremely powerful search library. So itself is not something that you could just plug in and talk with Ruby, except what is going on next door with Kyle's talk, where he's doing JRuby communication to Leucine. But a lot of people have built engines on top of that, and that's, of course, what solr is. It was created by this guy, Doug Cutting, who now works at Yahoo. He formerly worked at Xerox PARC and Excite search engine. And so he created this, to learn Java, he created Leucine in his free time. Leucine itself powers a number of systems out there, and there's a list of a few of them, including this IBM OmniFind Yahoo edition, which is a pretty sweet free search server that you can download and use, as well as a ton of other ones, including Wikipedia and Technorati. So what makes Leucine special? It's an inverted index under the covers. And what that means is that instead of just listing out all the documents there, it takes out the words, and they're called terms here, the words that you want to search on, and inverts that so that you can look just like a dictionary does. You look up a word, find the index in the back of the book. So you look up a word and find out what page the stuff is on. So the concepts that we have going on in there are documents. So you add a document. A document does not correspond to anything other than what you want to map it to. So it doesn't mean it's a physical file system file. It could be a record from your database. It could just be pulled out of thin air, just data that you grabbed from whatever, data that you crawled from the web. And so whatever you want to conceptualize as a document is what you map into it. And underneath the documents are fields. So you can have title, body, last modified date, permissions, popularity, any of those types of things that you want to put in fields. And fields themselves have a number of different types of attributes. So a field can be stored, it can be indexed, and it can be tokenized. And the tokenization is kind of the special process that takes the text that you hand to it, literally just a string, that you hand to that particular field, and runs it through an analysis process. And that analysis process takes the text and rips it into terms. And that process can do things like lowercase, or you could separate by white space. If you just want to blind kind of, just find the words that are in the text. Lowercase, it can do stuff like remove stop words, which is a search engine term, moving a, and, of, and the, that type of stuff. Very common words that in most cases are senseless to search on by themselves. And also it can do special things like stemming, taking the suffixes off of words and stemming it down to kind of a root form, so search, searching, searches, searched, those types of things, so that you can just search for the word, any of those variations, and they all stem down to the same version. So there's a lot of complexity, a lot of sophisticated stuff that you can build into this analysis process, and we'll take a look at how Solr deals with that analysis process. Now, another very special thing about leucine, we have a question? Is it plain text only is the question. Yes, that is true. So basically the only thing that you toss into fields is text, is a string. So if you want to index a Word document or a PDF document, something has to take that content out of those and hand it to leucine itself. Now, there are libraries that will do that, or open source libraries that will do that, and we do have some contributions already to the Solr code base to embed those types of document parsers inside of Solr. In the Java space, there's a lot of different parsers for those things, and I'm sure also in the Ruby world. So yes, you do have to just literally add text to leucine itself. But we'll see at a higher level that you can do more robust types of documents with Solr with the additions of these document parsers built into it. Another special thing about leucine is its relevance ranking. That's what makes Google special, and that you type in some words and the most important thing generally bubbles up right there at the top of the front page. And the same concept occurs with leucine, and what you see there is kind of the default similarity formula, the default score of a document based on the term frequencies, the inverse document frequency, normalization factors, as well as coordination factors. So if you do an OR type query, this word or that word, if a document has both of those words, that's an increased coordination factor, and it can factor into boosting documents up in the relevance scoring. There's a lot more sophistication than just what you see there in terms of the flexibility that you have with the scoring, but there's a lot of power and a lot of tunability that you can do in terms of playing games with relevancy. Okay, so Solr 101. What does it take to talk to Solr itself? Solr itself is simply a Java web application. So it's a WAR file that you can deploy into Tomcat or Jetty. Solr, by default, comes with Jetty itself. So you download Solr, you can literally just start it up right after downloading it. And to add documents to it, you do HTTP post. And that's the URL that you post into. And what you see there is an XML document. Now, the way Solr works currently is to add a document to Solr, you send XML in. There's also another built-in feature in Solr that's a little lesser known, but there's a CSV indexer built into Solr, so you can post in literally the contents as column separated. It doesn't have to be comma separated, it can be tab separated. Or whatever separator that you want, and you can post that in, or you can post in a URL to a CSV file. So it could be a local file itself and post that in, and that is a very rapid way to bring data into Solr. Okay, so that's the primary communication. We'll see we'll see different avenues of bringing data into Solr as we go, as it evolves. But currently, this is the way it's brought in. And to search with Solr, you simply do an HTTP GET, or you could do a post to that same URL. And what you get back depends on what kind of format you want. So it does not have to be XML. The default format that you get back is XML. However, you can add a simple attribute onto the request and get actual Ruby code back. What you see coming back from Solr is a hash, Ruby hash, and you can change that Ruby to JSON or to Python or XML, or there's also an XSLT if you want to get crazy with that kind of stuff, transformation that you can do within Solr itself. So you can get the data back in any format that you want, any usable format. And you could even write a custom response writer if you wanted to have any kind of custom format that you get back. So the bulk of the rest of the talk is going to talk about the Ruby library that I created that does this types of stuff with Solr. So it's going to communicate with Solr and add that WT, writer type equals Ruby, onto the URL that it requests under the covers. It's completely transparent to you that it's doing that under the covers, and that's what comes back, and that gets evaled on the client side. So what's solr-ruby? It's a Solr domain-specific language in a sense. The idea is to make a very clean Solr API that, of course, is in Ruby and is flexible enough to do clean stuff. So this is what it takes to communicate with Solr. So let me just go ahead and run a couple of examples here to show you up to this point here in real working system. Okay, so to start Solr, if that's big enough, if that's not big enough, let me know. Okay, so I just started Solr, and I've started Solr without any documents already there, and I'll show you how I can tell you that. There is an administrative interface, like I said, to Solr, and what you see here is how many documents are in the index. So there's nothing in there right now. There's lots of other cool things that you can glean from this administrative interface. All right, so what we want to do is add documents. And the example that you get when you download the binary distribution of Solr, you'll get a directory that's got these XML files in it, and there's a script. In fact, there's actually two different things. You can either post it with a shell script, and there's actually even a Java thing so that you don't have to, on Windows, you can just run the Java command line to post the stuff in. But I can say post.sh star.xml, and what that's doing, and you'll see the console of Solr going crazy there, posting those files, and it just posts all those things, and this is the response that you get back from Solr, echoed back to the console. And now back to the Solr interface here. So there's 26 documents that got indexed. And to search here, I can do that through the administrative interface if I'd like to, and simply search for the word Solr. And you can see the URL that's happening here, and I can even just clean it up to simplify it down to that. And what we see here is that hideous XML, and I can even pretty it up a little bit. And now when I view the source here, so there's the XML that came back from the search. It tells you how long it took, 1 millisecond there, and the status code and some other parameters there. And then the bulk of the results are the actual documents that match the query that I passed in. And that query is also echoed right here as Solr. Right, now, I can come over here and say I want Ruby code. And so there's Ruby code that came back. And like I said, just to show you, there's other formats possible. There's JSON, Python, and of course XML is the default one. Okay? So, but we're going to be working both with the Ruby response. Okay? Now, to deal with this through the solr-ruby API, first we'll let me just search for the word Ruby here, and I don't believe there's anything that matches. So no documents found. So back to that one example here. This is the solr-ruby library. You point it to the URL that Solr's running on. By default, it's port 8983. And there's a concept to Solr for committing. So you can add documents and add documents and add documents, and they are not visible from the front end, from searches, until you issue a commit. And what that commit does is tells Solr to refresh the index searchers, the index searcher that's being used on the front end, and warm up any caches that have to be warmed up. You can configure that so that your facets and all those other types of things are warmed up so that there's no lag in response time in between adding documents and warming up the stuff before when the searchers see the results there. So, and the Solr, you can issue a commit after every add. Now that's pretty inefficient because what that's doing is constantly telling Solr to keep warming up and refreshing at the front end. But if you're doing a bulk load, you want to just commit at the end. Just keep adding documents and then commit at the end.
If you have multiple processes running at the same time and one doesn't commit while the other is doing an add, do they keep a session for each one? Or?
Okay, so the question is if there's multiple processes adding documents at the same time and interleaving commits and that kind of stuff, that's totally fine. And that's actually one of the really cool things that Solr adds. For anybody that's actually dealt with doing stuff with leucine, you know that when you add documents to a leucine index, one, you can only add documents from a single process at a time. You can multi-thread that, but it can only be one index writer instance adding to leucine at a time. Okay? Now, with Solr, it manages that for you itself. So there is literally a single index writer on the Solr server side, but multiple requests can come in at the same time. You can add documents from multiple processes, no problem. You could interleave commits, and that's not a problem at all either. I mean, what will happen is you could end up committing a lot and stacking up. And there's actually a setting in there on how many on-deck searchers can be warming up. And you want to be able to tune that so that you're not crushing your server with commits that way and constantly warming it up. But there's actually no technical problem with doing that, other than you'd be beating up Solr for no reason if you don't need to see those results right away. The point about that is that Solr is architected so that it is scalable in the sense that you can set up a master Solr index server for indexing purposes and then set up load-balanced read-only searcher slaves that get replicated from the master server, so that when you actually issue a commit to the master server, it will, and it uses rsync under the covers, the built-in scripts, and you can script out whatever steps you want, but the built-in scripts rsync the leucine indexes down to the slaves, and then you can hide those behind load balancers so that you can scale out that way in terms of the searchers. And that's all just built into Solr as it lives right now. Any other questions at this point? Yes.
When it re-indexes, the re-index the whole or just the delta that was added?
Okay. The question was, when you re-index, does it index the whole or just the delta? Okay. So one point about leucine, and Solr, of course, lives on top of that, so it has to deal with the leucine semantics. There's no such thing as an update in leucine. You can't just say, I want to change the title of this one document. In fact, there's no such thing as a primary key to a leucine index. You have to invent that concept as your own field. You could have an ID field. That's your unique key for that. Solr adds the semantics of having a primary key, if you want, a unique identifier. You don't have to use that, but of course it makes sense to do that. So you have a unique identifier field. If you send in a new document, and in fact, this is a prime example here, there's an ID here, and in the Solr schema that we have configured, the ID field is the unique ID for that index. And if I send that document in, that very first document in multiple times, it's overwriting that document. So what it does is it actually deletes that document and re-adds it at the end of the index. The way the index is structured, there's no such thing as like an in-place insert in the middle of an index. They constantly are appending to the end, and deletes get flagged as deleted. Okay, so that's part of the scalability of leucine, is that it's not doing that type of in-place editing. It's adding stuff in. Now and I'll get to your question in just a second. There is a patch to Solr to provide a modified document thing in there, so that, in fact, one of the applications that I've developed leverages that so that you can actually send in just an updated field, and it will do the right thing on the server side and get that document and literally delete that document and re-add it, but you don't have to add you don't have to send those same fields every time. But with Solr, as it lives in the trunk or any of the release versions, you have to, when you send a document in, you're literally replacing the one with that ID or adding.
Is there any way for it to differentiate confidential memos from, everybody to see, public memos?
So, question. I'll just repeat the question. Is there any concept of security in there? And the answer is no. You build that on top of it yourself. So you could index, for example, roles with each document, and your application could, when it issues the query to Solr, say, only return me back documents that this role is allowed to see. But that's an application-specific thing that gets added on there. So Solr itself doesn't have any concept of anything security-wise at all, really. You have to build that on yourself.
Would you build that into the Solr instance, or would you build that into your web app that is talking to that?
So where would you build that security in? There's different ways that you could do that. You could build it in from your application, from the client side relative to Solr. And when you add documents, add the roles as a separate field there. And then when you query, you take the user and whatever roles that user's in and say only those documents that are associated with those roles would come back, for example. Or you could write custom Java stuff within Solr if you wanted to have a way to do something like that. But it would basically be doing essentially the same type of thing as that.
In Solr to do that kind of thing, where you don't have to re-implement all the stuff that's already there?
Yes. So there's in terms of Solr's pluggability, you can add your own request handlers. You can add your own response writers. It's a Java web application, so you could get in there. I've heard people in the Solr community talk about adding their own servlet filter to do authentication, so that you can literally add that authentication in there. And of course, Java's got all that, and Justin covered that in terms of you could hook in whatever kind of authentication you wanted through that Java filter if you wanted to. So lots of possibilities there. But again, Solr's primary and its only focus is the search engine itself, and doesn't deal with any of the security that you'd want to layer on top of that. All right, so let me just go ahead and run this script real quick. So I'm adding 2 documents, and we'll just make sure this thing works, I hope. Okay. What I did was add 2 documents, and they both have unique identifiers, and they both have different strings there. And since I was using auto-commit, as soon as each one of these adds is done, a commit is issued. And then I did a search, and of course I wrote the output out here. So there's the output. Now you'll notice that there's some additional fields that came back from that document that I didn't add. Now Solr has the concept of a schema. There's a schema.xml file, like all Java applications. You've got to have some kind of XML configuration file for some ridiculous reason. And so there's a schema.xml file, and that in there is mappings of the field names to what happens to those fields when you send them in from the client. What analyzers are attached to those. So when you send in text, what happens? How do they get tokenized? How do they get stored? You can also have fields that have default values. And in this case, there's a timestamp field that records the current time automatically to every field. This is the default schema that comes with Solr, the example schema. And in fact, I'll go further talking about that example application. There's a tutorial on the Solr that distributes with Solr itself that runs through the example stuff, and it talks about how you interact with all these things. It's actually extremely well written, and the Solr Wiki has an amazingly rich amount of information how tons of stuff work. So if there's anything I glossed over, chances are that it's answered on the wiki or in that tutorial. Not, as soon as you ask a question on the email list, the guy actually is very anal about adding it to the FAQ there. So Lots of great information out there on how this stuff works. And there's also the capability within that schema to copy a field. So you send in one field, and you can copy it to other fields under the covers. A common practice is to have a copy field for the bulk of your fields into a big blob of text, contents or text or whatever you want to call that. And so when you send in title and body and those things, they also get replicated and indexed. They don't have to get stored as is. They can just get tokenized and indexed into basically a big blob of tokens there that are searchable, so that you don't have to be field specific when you search. You can just search against that contents field. Now, that may not be the right way to go if you want to play interesting relevancy games with your fields, so that you search across multiple fields and tune which one rates higher and lower, that kind of stuff. But those copy fields are very interesting, and we can take a look at a Solr schema in a bit. All right, back to slides for a second, just to see where we are here. All right, so we ran that example. Oh, let me just go back to this for a second so I can show you the, I'll just rerun it. You'll notice that these scores are slightly different between these two things. Now, I searched for the word Ruby, or sorry, I searched for the word taste here, and both of those strings have the word taste in it. And however, the score is different. Now, why is the score different? Because there is a link normalization factor that goes into the computation of the score. And those two fields are slightly different links, slightly different number of terms there. I think one off by one here. So they do get different boosts based on the normalization. So you know, and that's a tunable factor. Is a word in a shorter field more relevant than that same word in a bigger field? That's one of those things that you can adjust. But that's the reason that these things came out in a different order than we actually index them, because it is doing the relevancy-based ranking there. Okay, so solr-ruby, the library, it's a very simple library. It's just doing that HTTP communication to Solr itself. Is under the covers of a plugin called AccessSolar. I didn't develop AccessSolar. It says that I did the first version on the website to it, and what I did was basically what you'll see in a later slide as AccessSolar Lite, a very, very simple rudimentary hack that I posted to the email list. And this guy Thiagos asked if he could take that and run with it and make it a lot richer, and he has done that. So the AccessSolar plugin is not part of Solr itself. It's a separate, I guess railsfreak.com is where it's hosted. So that's a plugin that you can literally just say AccessSolar in your ActiveRecord models, and it hooks into that. So anytime you save a record or delete the record or update the record, it goes out to Solr and does the right operation to Solr, and there are extra finder methods that it adds there. I have not tried AccessSolar in JRuby, but solr-ruby library itself works just fine in JRuby, yes. So I assume as long as ActiveRecord and just Ruby stuff, there's nothing magical there. So the solr-ruby library, the covers of AccessSolar. I also have created this glorious hack called Flare, and that is within the Solr code base as well as the solr-ruby library. Both of those are in Solr's Subversion repository. And it's a Rails plugin that adds methods to your controller. When you just put the word Flare as a keyword in your controller, it adds a bunch of methods, and it adds templates. I'm using the Rails engine plugin so that it comes automatically with some views, and we'll see what that looks like in just a minute. I created a project, again, we'll see this in just a minute, called Blacklight, that is a Flare front end on top of 3.8 million library records for the University of Virginia as basically a prototype. They haven't deployed it officially yet, but it's been running stably for the bulk of this year. And I created a system called Colex. Is Jamie in here? There's another developer here that is also working on the Colex project, and a folksonomy-based system that is a faceted browser on top of 19th century literature. Mainly. And is anybody else's app powered by AccessSolar or solr-ruby? Wow, so a handful of these folks. I'm sorry that I'm boring you with stuff that you already know. Let me just jump out here for a second so that I can show you what's happening with Solr when you do searches. The Solr console is echoing, and let me this stuff up at the top of the screen here. The Solr console is echoing out the requests that it receives. And I just want to show you how hackable this kind of stuff is. That search that we did from TextMate over here, this right here, what it did was do this to Solr. So it sent the /select with this right here. And this is the entire request that it did. So I just copied that, and I can come over here and just paste that here. And you can see that that's how hackable the stuff is, that you can easily kind of reverse engineer what's going on. For people that are using AccessSolar, if you ever run into any kind of hurdles or headaches with that type of thing, you can just look at what's happening to Solr and see what kind of request it's making to it, and just try to interact with Solr directly to get what you want, to kind of reverse engineer some of this stuff. All right. And I'll put this code up on the screen in bigger font in just a second. solr-ruby includes something I'm kind of proud of, but I've started to think about how to refactor this, and this is where and you'll see my cry for help at the end in terms of how do I design this type of thing into a very clean Ruby-centric way. What I wanted to do was have a way to take data in the Ruby space and put it into Solr, but have some way to transform that data into what Solr wants from your original schema, from whatever data source it may be. So I created this thing called a mapper, and all it is a simple way to take some object, pass it through the mapper, and out comes a Ruby hash that corresponds to what you want the Solr document to be, and it can then pass that on and index that. Okay, so the mapper itself has really nothing to do with Solr other than it's like an object to hash transformation. Now, the object itself needs to implement the bracket operator, and that's it, so that you can get at the particular fields. And let me just show you how that piece works here. What I'm going to do is, because Solr has a specific configuration, I'm going to restart Solr with a different configuration. And this is the AccessSolar configuration here. And back to the data so that you can see what I'm going to do here. Let's see here. Let me get my bearings straight here for a second. I just want to make sure we're pointing at the right schema here for this operation. All right, so just to verify that we have an empty index here, we should have 0 documents here. Now, just take a look at this script. This script is just basically within the Rails environment here, and here is the mapping. Now, the data itself is a tab-delimited file, and I'll show you that information here. This is, has anybody used the Mac application called Delicious Library? It's really, really cool. I just happened to have it up so you can see. Basically, you can turn on make your camera into a scanner. It OCRs the barcode of the book and hooks up through Amazon's Web Service the data. And I just have a little sample here. I just manually added these things. But this thing also allows you to export that data. So I've exported that data, and it exports it as a tab-delimited file. And here's what that output looks like. Kind of hideous here, but you can see that the first line is all of this, and these are the columns of data that are in there. So what I did was, and this is part of the solr-ruby library itself also, is I created a class called a delimited file source. And so I also created this concept within the Solr importer module of a data source. And a data source literally just has to implement the pound each. It really needs to be enumerable in a sense, so that it just keeps asking for data and getting it back. And then if you pass one of those objects that comes back through this mapper, and this is what the mapping looks like, it transforms that data, and then there's an indexer that knows how to use a data source and a mapper to pound every one of the sources, and then map that through the mapper, and then index that into Solr. So what you end up with is an extremely clean way to say, what I want to do is take that tab delimited file, and I want to index that into Solr. Now, the columns on the left of this hash are the field names in Solr that have to correspond with the schema, okay, the Solr schema. And let me see if I actually have a schema.xml in here so that we can talk about the Solr schema just a little bit. Okay, so this is the example schema that comes with Solr. And it's kind of ugly because it's all XML, but you see that there's an ID field, a name field. Now that's what I leveraged in that first example that I showed you, where I indexed those two documents. And so you have this. You can define your schema very rigidly here, or you can do things with wildcards. They're called dynamic fields. And here, the example schema comes defined with a handful of dynamic ones for different types of data. So an _s is a type of a string. That's literally, it's not indexed, it's just stored. Actually, it is indexed. It says true. It's indexed, but it's not tokenized. So literally, it's as is. Those makes for great facets. But fields that you want to search need to be type text here. Okay? And the way that mapping of type to what actually happens is up here at the top of the schema file. And these are the field types. So let's just take a look at the basic one here. Type text, and it looks scary. And this is what happens when you index just plain old text into Solr. During indexing, this analysis process occurs. During querying, this analysis process occurs. The difference is that during querying, synonyms are added. That's a synonym filter factor there. But during indexing, it is not, and it's commented out right there. Okay, and it has a comment in there that tells you what's going on there. So that's the built-in, the example schema, and that's kind of what makes the field name mappings map to the complexity of the analysis process under the covers. Okay, so in the schema that we're actually running with now, I have *_facet as a dynamic field. So I can add any field I want with the facet suffix. And what's happening is I'm extracting the data out of the input source here, which is that tab delimited file, and mapping them into fields in Solr. And so this mapping allows me to do things like I can literally add a field as is if I wanted to do something like fixed text, and I could put a string here, whatever I wanted. And that string literally be added as is to every one of the documents. And the mapping framework understands that this is a symbol, and what it does is pass that off to the bracket operator of the underlying object. And this underlying object here is one row of that tab delimited file. So I get back that column back and map it into the Solr field. Yes?
Question about the mapping of facets. I'm not clear exactly how this is working. So does that have to happen before the index is built, or could you change that after you already have an index?
So the question is, when do you, if you change your mappings and that type of stuff, can you change it after the fact without having to re-index stuff? I guess is kind of a related question in a sense, right? You do. There are things that you can do to your schema that do not require re-index, but there are a lot of things that you would do to your schema that would require a reindex of the data. If you change how tokenization occurs on a particular field, you have to reindex your data. If you're going to add a facet, you need to make sure that that's in the index for each one of the documents at index time, yeah. Is that okay?
And when you say reindex, do you have to get the source documents again, or well, you would have to for the tokenization, but...
well, that's not entirely true. This guy over here asked about being able to update a document. Now, you can literally store, so within, let me back up for a second and show you a cool tool that I would have neglected to mention had it not come up here. There's this tool called Luke, and it's a Java desktop application that is a leucine index browser. Luke is showing us what makes that leucine index tick. Let me just make sure that let me reopen that current index so that we're there. It's got 28 documents in there, and I can go through the Documents tab here and scroll through these things. And you notice this column here. These are all the different types of flags on that particular field. Indexed, tokenized, stored. Some fields get stored. So you could literally store the full text of every field that you send in within the leucine index. Okay, so your leucine index is going to be like, the size of your original stuff plus what it takes to invert the stuff and actually index it too. If you have a stable document repository and you don't need to store the text within the leucine index or in Solr itself, you can just index the stuff but not store it. If that makes sense. So you can do tricks with that modified document feature that's going to be coming. It's in patch form now. You can do tricks where you can in place re-index documents within the index itself by simply touching those things and changing the schema and kind of touching them. So there are tricks that you can play, but you do have to have the original text to re-index stuff somewhere. So you may have it externally to Solr, and chances are you do, and I certainly would recommend that you actually do that because you want the index itself to be rebuildable from scratch because you're going to want to tune the tokenization processes, and chances are you're not going to want to store the content within the Solr index. Depends on there's a lot of it depends kind of stuff with all of these things. Okay, so I'm glad I got to show you Luke. This thing allows you to do all kinds of interesting things. Here's what a leucine index looks like under the covers. It's all kinds of special black box files. It's literally just a directory on the file system with all of these magical files there. You can do ad hoc searching in here.
Is it safe to have those files on NAS, or do you need SAN storage? I mean, does it need to be a block device?
Say that again. You have the leucine index itself?
Yeah.
The only thing that's kind of a negative out there so far has been NFS file systems, but that problem has been resolved in leucine and basically in the trunk code base of leucine now. But other than that, there's no real restrictions on that kind of stuff. The right field to search on here. Sorry, you can ad hoc query for stuff. There we go. Okay, so and you can see the results in here. It's just a really nice tool to be able to browse around the index. You can browse through the terms of the stuff. You can look at this document and see what makes this document tick. I can look at the name field here. I can see this is what the original text is because that's a stored field. It's within the leucine index. And I can see how it got tokenized. Let's see the name here. Okay, so you can see that interesting things happen. The spin point word actually got tokenized as spin and then point and spin point. And there's that weird bar is actually kind of a separator saying those two terms are in exactly the same location. Within the way the terms are, there's a position increment from term to term to term, and you can say that two terms actually lay in the same position. For synonyms, for example, you might want, for highlighting purposes and that kind of stuff, you can lay multiple terms in the same position. There's all kinds of interesting things that the analyzer can do with this kind of stuff. So the mapping framework allows you to do the symbols to pull data from a source, from an object, and I have a feature in there for putting procs so that that code actually gets executed as it's happening during the transformation. For example, the genre field in the original data is actually slash separated, so the Amazon data of all the different categories for particular books have slashes in between them. I want to split that out and turn that into a genre, multi-valued genre field itself, so you can do all kinds of, you can do any kind of transformation you want on the data there. I'm extracting the year here, so that, and all I'm doing is pulling out 4-digit years. Nothing kind of crude there, but that works to get the years out of the published date. And so the indexer here is taking this book's source, which is a delimited file source against that particular file, and applying this mapping and then indexing it into Solr. So let's go ahead and run that. And let me just make sure that I'm running the right one. Okay. And come over here and import that file into Solr. And we'll go back to the console, and you'll see that thing updating constantly there. There's like 160 records. And then when it's done, it'll come back to us there. And so now, over in the console, we'll see instead of 0, we'll see 163. Okay, so we've now indexed that file into Solr and divided it into documents through a very straightforward process of give me a data source. Again, this data source, literally, if it quacks like pound each, it can be iterated through. And then what gets returned from that pound each literally just has to moo with pound bracket and be able to take that symbol and give you back the data from each one of those records. And then you can index into Solr with that mapping. And I did this with sophisticated library data, and I created a custom data extractor to extract data from, a MARC data file, if anybody's familiar with that world, and made it so that librarians themselves, catalogers, could look at this mapping and see how the data was being indexed, and literally just correct any misunderstandings I had about how that was. And so it worked out really well to come up with this clean mapping stuff. I've also been able to use this mapping to take data and literally add it straight to ActiveRecord. So let me go ahead and show you how that works. And this segues into the AccessSolar example. All right, so I want to create my book model here. And if we're looking at over here, we see that in, models, we have a book model, AccessSolar, and there's a way to specify what the facets are. And I'll show you what facets are in just a second. I know that may seem a little mysterious there, but you'll understand in just a second. Now, this import to AR is leveraging this mapper, but what's happening under the covers is it's literally just going through, calling that pound each on that data source, which is that tab-separated variable file, and using the mapper to map that tab file into attributes for ActiveRecord. Okay, so what I'm doing is, and thankfully, the ActiveRecord allows you to take a simple hash here, and that's what the output is from the mapping, and create something straight from that. So what I'm literally doing is just adding records to ActiveRecord to the database, but because I've got AccessSolar plugged in there, that in turn, that process in turn is going to write straight to Solr also. Okay, so there's no Solr going on inside of the script per se, but the fact that we're using ActiveRecord is going to do that. Now, what did I break here? All right, so demo breaks. That's great. I'm not sure what I did there. All right, well, we'll just move on past that. I'll try to come back to that in a minute. Okay, so AccessSolar gives you the finders so that you can do find by Solr and get information back. It also has this find with facet, and here's kind of what the facets give you back. You may have a field for this, in this particular case, publisher, and you want the count, you want to do a full text query, and then within the results of that, you want to know how many of each one of the publishers there are in that result set. And so the facets give you that back. Now, one of the things I'm not fond about AccessSolar is, and this is just because there's what it does is translates names back and forth between what's in the Solr schema and then what the ActiveRecord model says, is you've got a field called publisher, but what you get back is publisher underscore facet in the data. So there's a little bit of mismatch there. Yeah.
Is there still a database record when you say book.create? Is that creating a row in a books table?
Yes.
Just going into Solr?
It's going into, so basically what you see in this script here is the book.create. So that's pure ActiveRecord. There's nothing in here that's writing to Solr. But because I'm doing a create on that model and the AccessSolar is inside of that model, the create there is going to Solr. So my process here knows nothing about indexing to Solr. It's just creating records in the database. Well, it would be if it didn't break. I'm not sure what happened there. I've got multiple schemas and multiple setups here, so anything can happen. All right, so there's nothing really magical about what's happening with AccessSolar, and in fact, you can create your AccessSolar Lite like this, and this is basically kind of the hack that I had created initially with AccessSolar there. So I'll just quickly show you that, and that is this Lite here. And all that is this after save and after destroy, and then doing the right thing here to Solr to add it and to delete it when you remove it from Solr. So that's nothing magical about what's happening with AccessSolar. It's just doing a lot of transformation of field names and mappings and that kind of stuff under the covers for you and adding finders. So there's really nothing magical there. Now, sorry, I got run away with time here. Flare. This is what Flare looks like. Let me show you in the browser. This is Flare on 3.8 million records, and this is library data here, so I can see different, if we're online, we'll be able to drill in and do stuff here. Might not be. All right, so basically Flare gives you everything that you see here in terms of faceting, which are these counts down the right side here, and as I drill in, I'm narrowing down my constraints to music CDs in the rare book format and drilling in that way. So there's tons and tons of these facets here in the library data. But Flare gives you all of that without having to do anything but put the word Flare in your controller. And I can do full text queries there within that data set as well. And let me just go ahead and wrap up. I'm right at the end of time here. The future of solr-ruby, we want to do more stuff that is integrated with Solr itself in terms of grabbing the schema. You can just do an HTTP request and get the schema or the configuration and make it savvy in that realm so that you could validate the documents that you're adding, make sure the fields map and everything. I want to bring the AccessSolar stuff into the solr-ruby library. Thiago's already agreed to contribute that back, so we'll figure out some way to integrate that. And there is an interesting issue with the XML response that you can do with Solr versus what you get back with Ruby hash, and basically the XML can give you back an ordered hash, but you don't get that back when you with the Ruby response. So there's a little bit of data loss there in the Ruby code that comes back. So I want to sync that up and maybe come up with a different response writer for that stuff. There's a lot of places to go with this stuff. I certainly welcome any kind of guidance people want to give me on the domain-specific language or the API there, how to do ActiveRecord integration better if it needs to be better from AccessSolar. Certainly documentation is lacking on a lot of that. And I'm curious about how Apache itself, I'm a member of the Apache Software Foundation. I'm curious how we can do more in terms of the Ruby space. I'm not sure what other projects out there in Apache land are Ruby, but Buildar is coming, so it's in incubation. So should Apache be a gem server, that kind of stuff. And I've contributed 3 recipes to the Advanced Rails Recipes book that's coming sometime in early next year. So see those out there. I probably should rev those to make sure they keep up to date there. I contributed them a while back. And there's contact information if you want to touch base with me about any of this stuff. And I think I'm completely out of time here, but thanks.